Okay, pre-calc, here we go with our first lesson in the new unit. This is going to be a unit all about limits, and we're going to talk about how to find limits. This is really probably the most applicable stuff when we start talking about calculus, because calculus is really based off of limits and the definition of limits. So first thing first, we're going to talk about how to find limits in a very basic way today. We'll talk about how to use a table to do them, kind of like using a table to graph. Then we'll talk about what a one-sided limit is, and then how to actually use a graph to find a limit and their relationship with one-sided limits. So to start, what we want to think about is a function like we have here. Okay, and if you remember back from first semester, and we talk about domain, we would say that x cannot be 2. But that doesn't mean that we don't have a limit here. If I were to plug in two different values, if I plugged in 1, I'd get -3 in the numerator over -1 in the denominator, or a value of 3. That would work. If I plug in 2, I'd actually have 0 in the numerator and 0 in the denominator, and since we can't divide by 0, this would be what we say is undefined. Okay, there is no solution for that, because 2 is not actually in the domain of f of x. Now, it's going to be important for us to understand what a limit is, because it's going to help us understand what those values equal to as we go. So, as x approaches 2, that means from both sides. So that means from the left, or values that are less than 2, and from the right, or values that are greater than 2. So first of all, when x was 2, we already know that it was undefined. I'm going to choose some values that are just less than 2 and approaching 2. So they need to get closer and closer to 2 as we move to the right here. Now I don't want to choose like -1, 0, and 1, because those are still relatively far away in terms of how many numbers exist between them and how small our incremental changes are. So I'm going to choose 1.99, 1.9, 1.99, and 1.999. Those are getting really close to 2. I'm going to do the same idea on the right side. So this is to the right side, are values that are greater than 2. So far away, we're going to say is 2.1, then 2.01, and 2.001. And if I plug all those into the calculator, the values that I'm going to get out are 3.9, 3.99, 3.999, and they're actually going to be the same as we approach from the other side. Which means, as x approaches 2, f of x does not equal, but it does approach, and you see these numbers from both sides are getting closer to 4. In fact, we should have another 9 there. Okay, they're getting closer to 4. So that tells us this is called the limit of f of x as x approaches 2, and we will write that, the limit of f of x as x approaches 2 equals 4. And so that's what the limit of f of x in this case means. If we look at another one, limit of sine of x over x as x approaches 0. So we've got some function here, or some equation that we're going to use, sine of x over x, and we want to know what happens as we get closer to 0. So the graph will be undefined at 0, so we can't just plug that in. We can, however, create a table. So I'm going to do that real quick. And then we're going to put 0 in the middle, and we know that that is undefined. So I'm going to have that right there. And as I come from each side, so I'm going to throw some lines in here. Okay, and we don't need a ton of boxes, but we'll do it like this. Okay, and we know this is x, and this is what we're calling our function f of x. So numbers that are just less than 0. So now I need to be looking at negative numbers like -0.1, -0.01, and -0.001. So you see each time I'm just getting closer and closer to 0. On the other side I need to be positive, because now we're to the right, or values greater than 1. So I'm going to say 0.1, 0.01, and 0.001. Okay, if I go ahead and plug those in, then here at -0.1 I get -0.998. And then I get -0.999, and then -0.9999999. These are going to go on for a long time. Oops, I'm sorry, these should all be positive values here. And then from the other side, really, I'm going to get the same thing. So 0.999, and we're going to have a lot of 9s here. So you can see that as we approach 0 from both sides, really, we're approaching 1. Okay, now it's always important, these two don't have to be identical sets of numbers, but if they approach something different, so if they approach something different, then we're going to say the limit does not exist. And we can just write that as D N E. Okay, the limit does not exist. So moving on into one-sided limits. So we're going to have two things, what are called left-sided limits or left-handed limits, and right-sided limits or right-handed limits. And left-sided or left-handed limits just means the limit of the function as it approaches numbers from the left, meaning from the left is less than those numbers that were to the left of the table on the box that we just looked at. And our notation, the limit of f of x as x approaches a, we put that little minus sign right there. That's the important piece, and that means that we're approaching from values less than it, or from the left side. A right-hand limit then is just the opposite, the limit of a function f as x approaches some value a from the right, and again from the right this is going to be then more than or greater than, and you can imagine that our notation is very similar except for instead of a negative sign now we have a plus sign, so that just means values that are just greater than a. The reason when we talk about that is because a limit doesn't always exist, and if it is going to exist, then our left-hand side and our right-hand side have to be equal. Another thing that may be true now, if we look at our graph, is I've got four things I want to look at here. So you can see we're looking for the left-hand side, the right-hand side, and then the limit overall when we don't put a symbol there, and then what is it actually at, f of negative 2. If I look at my graph, f of negative 2, I see that I have an open circle here. F of negative 2 is closed, so this is where we actually exist for f of negative 2, and that's going to be at negative 5. So I jumped ahead and did that one first. Now I need to go back and do these first two before I can talk about what the limit of f of x as x approaches negative 2 actually is. So from the left, again, means values that are less than it. So from the left, if this is negative 2, values to the left of the graph coming towards x is negative 2, I am using this piece of the graph. And so that's going to give me a value of negative 5. If I talk about then values from the right, well, from the right now, so this is to the right, this is to the left. From the right, you see I'm actually using this graph. And we want to come back towards negative 2. So we're not reading it left to right all the time. We are coming towards the value that we're talking about. Since we're talking about negative 2, what's happening as we're getting really close is coming to this open circle, and it doesn't matter that it's open. We just look at the y value that we're approaching, and that is going to be negative 1. Now, since these two values do not agree, we actually say that the limit does not exist. There is no limit at negative 2 because the graph doesn't approach it identically from either side. And so the big thing here is we can have existence at a value. So we actually exist at negative 2, that's negative 5. It does not mean that the limit exists, and it also does not mean that the limit is that actual number. Okay, that is it for this lesson, a good introduction to limits. We'll spend a lot of time going over the graphs and reading them, one-sided limits in particular with our graphs, and do they agree with the limit as a whole. Okay, we'll see you next time.